Welcome back, Math 30-2. Today we are looking at exponential growth and decay. This is going to be very related to the lesson before, lesson 7, which dealt with finance. Now if we remember back to finance, we looked at this formula here. And in this formula, we always had an initial amount of money, and then we multiplied it by 100% plus 5%. So it's always a growth to get a certain value. Okay? That is what it was, and it was compounded, and it was a growing over time. Now, if we're looking at stuff like population and many other forms, sometimes there's a decay, or radioactivity. Sometimes there's a decay, sometimes there's an increase, right? Populations of some countries go down and towns go down, cities increase. And that's what we're going to look at today, is population increase and decrease. So exponential growth and exponential decay and how to solve. So here's our first example. It says, a quantity of water contains 500 grams of pollutants. Each time water passes through the filter, 12% of the pollutants are removed. Alright, so it says right here, state the base of the exponential function. Well, so the mass of the pollutants is the exponential function. State the base. Well, we're always starting with 100%, which is 1, right? Our initial is always 100%. And what happens? We're decreasing every time by 12%, which is equal to 0.88. So my base is essentially this part right here, or my base there. So we want to know what the base is. Well, that is how much we're always increasing or decreasing by. And every time we're only going to have 88% of the original population, or of the population before when it was last looked at. Okay, so in this case, the exponential function could be termed with this, modeling this scenario. All right, but now we're going to use this formula here, where my initial mass, time, and this is my final mass, okay, of pollutants. So let's write this formula. Well, my m is what we're trying to find out. My final mass of pollutants is equal to my initial mass, which is 500, multiplied by, and we're always going to have 88% every time. Every time we only have 88% of the original and time, because that's 100% minus 12%, going down by 12%, so we're only going to have 88% of the original all the time. So this is my exponential equation. So after 5 years, we go down by 88% 5 times, or we only have 88% of the original. We don't really go down. We go down by 12% 5 times. So we only have 88% of the original 5 times if it was 5 years. So we have to multiply 88.88 by 500 5 times. Okay? Now, here's the next one. It says, determine to the nearest gram the mass of pollutants gained after the water has passed, or sorry, not times, this T's for filters. So determine to the nearest gram the mass of pollutants remaining after water passes through 4 filters. So all we do is we go m is equal to 500 multiplied by 0.88 to the power of 4. Because there's 4 filters, so every time it's 88% of the original. So here's my filters that go down. 88% of the original comes down, hits this one. 88% of what made it through hits that one. Then 88% of what hits through the next one. Then 88, so it keeps on going down like that. So we multiply by 0.88 4 times, which will end up giving me a total of 299.84, which is approximately 300 grams. So we want to the nearest gram. Okay. Now the next one says, how many filters are needed to reduce the pollutants to less than 150 grams? So we're reducing the pollutants to less than 150 grams. So this is equal to 150. And now we want to know how many filters there are that make that. Well, I'm going to think about this. This is an odd base. It's going to take me forever to do that, right? So I'm going to isolate for my variable best I can. Divide both sides by 500. So I get 150 divided by 500 is equal to 0.3. Alright, it's equal to, now, 0.88 to the power of t. Now, what do? I'm going to have to log both sides, because I can't solve for that t, so I'm going to log both sides. So I'm going to log 0.3. Now this is just like the other classes we had. And the t goes in front. Now I divide both sides by log 0.88. So I end up getting t is equal to log 0.3 divided by log 0.88. And now what does that give me? Well, I punch that into my calculator. I'm going to get 9.4 filters. Well, and it goes on. 9.4 filters. Well, can I have half a filter? No, they're full filters. And we want less than 150. So we need at least 10 filters. Because 9 filters, there's going to be a little bit more than 150. So we are going to need 10 filters for this one. So we have to round up. Okay, to 10 filters is what is needed. All right, so there we are. We're done example number 1. So here, we're going to take a look now at example number 2. Example number 2 says, the number of students at a new college is currently growing at a rate of 4% per year. That /A means per year. The number of students continue to grow at this rate is projected that the college will reach a maximum capacity of this much, 5,650 in 4 years. Now this is asking us to determine to the nearest 10 students, so last number is going to be a 0, the amount of students currently. That's interesting. So, let's go with this. So what do we know? I know my final population. This is my final, and it's after 4 years. So I'm going to put that in. 5650 is equal to, well, I don't know my A, my initial population. Do I know my base? Well, we increase 4% per year, so it's 1.04. It's kind of like the finance question, isn't it? And now how many years do we have? 4 years. So now we're trying to find my A. Well, that's not that bad, is it? No, it's not. I could figure out what that is, and I could figure out what the other one is. So I'm just going to isolate for my variable. So 5650 divided by 1.04 to the power of 4. And that's going to give me what my initial is. Or I guess you could say principal for using this. The finance would be a P. And that is going to give me a total of, my answer is, my initial is 4,830 if we plug that into our calculator. And that's our final answer. So that's how many students there are. It's actually 4,829, but we want to the nearest 10th, so it has to end in 0. So it's around 4,830 students. Okay? All right. Let's take a look at the next one. It says, the governors of college decide to expand the school by adding more buildings, which will increase the capacity to 8,000. All right, so we're increasing the capacity to 8,000. In order to determine the number of years it would take before the college reached full capacity, when the government used the growth equation below to solve. All right, so we used the equation below to solve. He realized, though, soon realized that his answer is not correct. Where did he make the error? All right, so let's take a look at this. Line 1, we have this here. Line 2, he decides to, well, we have exponents, so he logs both sides. But he logged all of this here. Where did he make the error? Well, I know there's an error in line 2, because first we have to isolate from my variable the best we can before we log. So in line 2, he made his error. Line 2, he made the error. Because the n, and the idea of that is this n is only applied to the 1.04. It's not applied to both of these. So then when he puts that n in front, there's my mistake. Okay, so in line 2, he made the error. So the n only applies to the 1.04. And it doesn't apply to the other one. Okay? Now, that is my problem, because the n only applies to the 1.04 and not the 4830. So now it says, let's try and solve this. Let's do it properly. So we have 8,000 is equal to 4,830 multiplied by 1.04 to the number of years. Or we could put t, n, whatever you want. Okay? Well, first thing we want to do is isolate for my variable the best we can. So I divide both sides by 4,830, so I get 8,000 divided by 4,830 is equal to 1.04 all to the power of n. Now, that looks good. Now that that's like that, I could log both sides. Okay? Another thing we could have done here before I go on is from this step to this step, he could have done something else. He could have done this, log for 830, and then he could have plus log 1.04. He could have done that as well. Why? Because when multiplication happens, that's two additions. This makes an addition, so we could use that rule. So we could have done that instead as well. And then he moves this to that side, and then it's a subtraction, and that means this will be divided by that. He could have gone that way as well, but I'm doing it this way here. So we just keep a easy motion. So if I continue this, I'm just going to log both sides. So I get log and my n's in front. Now think of if we separated this. This is log 8,000 to subtract log 4830. Well, isn't that the same as if I moved this to that side? It'd be log 8,000 subtract. So I could kind of do it this way, but then I have to remember that this is the same thing as adding. Okay? Next part is, well, let's take a look here. So we could have done this way, but remember, this is multiplication, so we can't just bring this n out there. It doesn't work. Okay? So now, what's the next part we should do? Well, let's figure out what this is. That's going to give me something. And divide both sides by log 1.04. I'm going to leave that until my calculator at the end. Okay? So I end up getting n is equal to log 8,000 divided by 4830 all over logarithm of 1.04. And we plug that in my calculator, I'm going to get 12.8. Okay? So if I say 12.8 years, well, it'll be on the 13th year they're at max capacity. So on the 13th year, they will be at max capacity. Does that make sense? Hopefully. Okay. Last set of questions here, and we're dealing with half-life. Alright, and doubling life. Half-life, well, we're always going by that, and it's divided by the number of years it's half. So if I said the half-life of I don't know, a mosquito population, they spray it and the half-life will be, they go by half every 3 hours. Well, after 2 hours, are they at half yet? No. So you need 3 hours to fill out the 3 there. That means they're at half, so 3 over 3. So you put the amount of time it takes to make a half-life on the bottom here, and this is your thing there, okay? So that's a way of thinking about it to understand the formula. And here will be a better example as we come up. Okay, so it says, in April 1986, a nuclear accident in Chernobyl contaminated the atmosphere with quantities of radioactive iodine-131. If the half-life of iodine-131 is 8.1 days, determine the number of days to the nearest day it took for the level of radiation to reduce from 100 units to 2 units. Okay? So, we have initially 100 units. We want to know how long it takes to go to 2 units. We're looking at the half-life of this. So it's 0.5 every time we're going to be halving that. But how long does it take to make one complete half-life? Well, it'll take 8.1 days. So if my t is 8.1, that is 1/2 to the power of 8.1 over 8.1 to the power of 1. So that's my time there. That is why I must divide this by 8.1. Hopefully you get that. It's kind of crucial. So I'm going to start solving for this. First thing I'm going to do is divide both sides by 100 to isolate this, my variable, the best I can. And I'm going to end up getting 2 divided by 100. Well, that's going to be, let's see here, 1 over 50. Okay? Which is 2%, or 0.02 if we want, is equal to 1 over 2. And I have t to the t over 8.1. Now I'm going to log both sides. And I could put this t all over 8.1 here. Okay? Now what must I do? I'm going to divide both sides by this log 1/2 or log 0.5. So if I do that, I'm going to end up getting t over 8.1 is equal to log, the logarithm of 0.02 all over logarithm of, well, 1/2 same as 0.5, 0.5. Okay? Now, I continue this. T is not quite by itself. What do I must do? I must multiply both sides by 8.1. So that's multiplied by log 0.02 all over log 0.5. Alright? Now if I put that into my calculator, I'm going to end up getting a total of 45.7 days. Well, I can't have 0.7 a day, so we're just going to round it up and say 46 days, there will be 2 or less. So 46 days. That's a Y, not a G. Okay? There we go. The next question, last question before your assignment. A patient feeling ill had a sample taken of bacteria. The sample contained 387 cells. Okay? Now, 24 hours later, the sample was recorded and found that can contain 8,012 cells. So my initial is 384, or 387. Okay? Now, our final is 8,012. Well, we're increasing. So my exponential must be greater than 1. And then it says it wants us to find the time of bacteria to double. So how long does it take for it to double? So we're doubling. Now, how long does it say for that? 24 hours later. So that's 24. Well, 2 to the power of 24 is going to be a big number, is it? So for our doubling time, we want to know the time it takes it to double. That is this guy here. So this is going to be my, I'm going to put my x here. It doesn't matter what you put it. I'm going to say my doubling time, which is x. That's my unknown. Why? Because, well, if it's 24 hours, it doubles in 24 hours. We want to know the time for doubling. Time is always with the exponent, or the how many filters. So we're going to look at that now. So how do we solve this? First, let's simplify this. I'm going to divide both sides by 387 and isolate my exponent. So I have 8,012 divided by 387 is equal to 2 to the power of 24 all over x. Okay? Now I continue this over here. I'm going to have to what? That's the best I could do. Log both sides. I could also just change a base, say log base 2 is equal to this, but we're going to be calculating with our calculator, so I'm just going to keep it like this right now. And we have 24 all over x. Okay? So now, what are we going to do? Well, let's multiply both sides, or divide both sides by log 2. Okay? So now we end up getting 24 over x is equal to log, well, this big number here, 8017, all over 387 divided by log rhythm 2. But here my x is on the bottom, isn't it? It is on the bottom. So I'm going to have to flip that. So this is going to give me the same thing now. I'm going to have to cross multiply here. Or else, so I'm going to have to cross multiply. Put this on top and this, and divide 24 by all of this. I must divide by all of that. So I'm going to end up getting x is equal to 24 divided by log, or I could say multiply by log 2, divide by this, right? Log 8017 all over 387. And it's multiplied by, because I'm just flipping this, log 2. And I plug that into my calculator, I'm going to get 5.5 hours. Or 5.48, which is 5.5 hours when I calculate that. If you have some problems with that, you could come and see me how I went from here to there, and I'll help you out with that. It's just our fraction rules and solving for x when it's on the denominator. Well, good luck with your assignment, and I'll see you tomorrow.